لسه بنتكلم عنك دلوقتي، قلنا كده
انا
الاوديو
لسه
بيكونكت.
كنت بحاول ادخل. ايه الاخبار؟
اهلا بك محمد. الحمد لله. اهلا
اهلا
وسهلا
بيك.
دكتور محمد. منور معانا طبعا دكتور محمد. لسه كنت
الله
بقول لهم
يبارك فيك.
هتروح بقى تزور الكوانتم انوفيشن سامت وتاخد اطلاله بقى على الستيت اوف ذا ارت بقى اوف كوانتم كومبيوتنج وكده. احنا طبعا هنسويتش الانجليش عشان يعني عندنا هيبقى عندنا جيستس كده من بره.
انترناشونال.
اه. Okay, so we were just introducing you that you are gonna visit the Quantum Innovation Summit. So that's a good way to have a visibility about quantum computing and the state of the art of quantum from all of these startups, organizations, and the companies coming from Europe and the US to have this 2 days event in Dubai.
Yes, inshallah, tomorrow I will be there, and I hope that I can get a good connections and make a nice networking. This is the first time, so I'm still a bit curious what will happen there. So, of course, I will update you somehow about what's going on there and what's the potential opportunity that could be also benefit us, and how can we expand also in Gulf. So, inshallah, it's a step ahead, and I wish that we can do something there.
Yeah, then that will be great indeed. And hopefully, yeah, you will maximize your benefit from there. I don't know if we need to start now because we have already our attendees. And so the system of today, we are gonna have presumably 2 breakout rooms that are gonna work in parallel. I might take one of them after we finish the main presentation. We can separate them also based on the language. This will be the initial obvious. If we have Arabic speaking attendees, it will be preferable to have their own breakout room, and then I can help in the English part. And yeah, and this is gonna be, and then we're gonna have so sort of general discussions where attendees can explore or ask whenever they are wondering about in quantum computing, or things that they don't understand, or they want to a highlight, or to have just a conversation. So that yeah, that would be great indeed. So I see people are coming in.
I think it's better to be seen by the others somehow.
Yeah, we are being seen by the others now. So we are live.
Yeah.
So they are, yeah, so we are live now. So they are seeing us, but of course, they are gonna interact when we just have the split out the breakout rooms. Okay, so I tried to find my iPad bin just to explain things by hand, but it's a bit complicated because I have an old iPad, so it doesn't support things anymore. So hopefully with this little tablet, we can just do some illustrations with it, which is not nice as the iPad, but of course, prices of tablets are becoming insane at the moment. So especially the ones that are really smooth with pen. Yeah, so hopefully this little tablet will just do the job. Okay, so more and more people are coming. So maybe we can just start for the sake of time. So welcome everyone. Today is a Quantum Lab session. It's a follow-up session on yesterday's session, which is the second edition of the monthly series, Quantum AI, that's organized by Bibliotheca Alexandria and iQafé Academy. and also the team of Quantum AI Lab, which is mainly active in Egypt. And today we are going to talk about the practical session or the practical part of this monthly series. And we are going to start by learning about how to program or make quantum algorithms, and also how to apply quantum computing methods and use them to solve some problems. But to just start, we are gonna start just by introduction, how we are gonna use a quantum computer, what do we need from it, and have a quick overview on the functionality of the quantum computing software development kit like Qiskit. And then we are going to have the practical part where we will have several breakout rooms. And in this, you are going to solve, I'm going to send the link, you are going to download the notebook, and you are going to execute some exercises with the help of our Quantum AI Lab mentors. And we have here Gamal Moneep and Dr. Mohamed Yehia. And before I start, I would like also to thank Mr. Youssef Eldakar for all of the organization and the efforts putting there. And also
It's
thanks
my
our
the pleasure of the Bibliotheca Alexandrina. Thank you very much.
yeah, thanks Bashmans Youssef, and also our mentors Mr. Gamal Moneep and Dr. Mohamed Yehia. So Bashmans Youssef, if you have any word to share, yeah, please go ahead.
Just saying welcome and thank you for everyone for participating, and especially to our mentors. And of course, once again, thank you very much, Dr. Taha, for all the effort, and wishing you a very good lab. And again, always looking forward to the hackathon in September. All the best.
Yeah, thank you very much. Okay, so I'm gonna start now quickly by highlighting what we mean. I'm just gonna come sharing my presentation. So the presentation that I'm gonna present now is part of a public repository of a workshop that has been already offered where I introduced it last year in Amsterdam, and the repository under the MIT license. And for the Quantum Lab, we are gonna share another link where you will need just to download this notebooks using it with Colab or use them locally on your computer. Okay, so I'm just getting my arrow. So hopefully everyone is seeing the screen. So to start with quantum computing, we need to discuss very important concept, which is the classical superposition and the quantum superposition. And you will understand this in our applications later, because there's a lot of people who make confusion about this. So in practicality, quantum computing is similar in a way to classical computing. However, the only thing that is different is the way that you deal with information and the processing of information, and also how you are gonna load your information to the fundamental bits of information, and also extract the information from and processing it. So in classical computers, we do have these classical computers. We have our hard drives. We can just encode information on it. In the old media, we have this magnetic media where you just flip some spins, and you work with spin tronics or this spin electronics, and then you can encode or load something on this. Similarly with a DVD and so on. But when it comes to quantum, you would like to use powerful properties of quantum mechanics and the quantum world to do computations. These powerful tools and the powerful properties come from the idea of the superposition, and also that your fundamental units of information, that we call them qubits, can entangle together and they can exhibit fundamental properties or fundamental quantum mechanical properties. Before we step into this, we have the concept of superposition. and that concept is very important. So if we come to the concept of superposition, that in classical mechanics, it means completely different meaning than in quantum mechanics. So in classical mechanics, if you have two waves, I'm just gonna show this now. So if you have two waves like this, you would like to calculate the amplitude. You just add these two waves together. You make a sum, and that sum will tell you about the resultant or the superposition. So you'll get a resultant wave, either by constructive interference or destructive interference. So you can have two waves like this, and then based on the combination between both of them, you will get a sum or a resultant wave function or waveform like this. When it comes to quantum, it's completely different. We don't have this at all. We only have one situation that can survive. So if you have a quantum system that exists in two states, it doesn't mean that we add these two states, so we cannot have a collective effect from the two states. We only can have one situation at a time when we measure. So only one situation survives. This is completely different from having two water waves that overlap with one another, where you measure the resultant amplitude. So either they can have a destructive interference, a constructive interference, but when we come to the quantum part, this is not the case. We only find one particular situation. And this is very important because still some newcomers to quantum mechanics, they think that they can project the classical notion on the quantum systems or qubits. However, this is not correct, because the way that the definitions or the concepts are defined varies from the classical notion and than the quantum notion. Okay, so I'm gonna back to the second presentation. So for that, in brief, in quantum mechanics, we have we describe the quantum systems by a wave function, and we just need to write this wave function. So we can write them analytically like this, or we can write them using what we call bracket notation. And this bracket notation is just a borrowing of the way that we write vectors. So you can, if you have a vector in 2D plane, you can write the component or the projection of these vectors on the axes x and y as a1, a2. Similarly, in 3D space, you can do the same. So you can have like three components, a component on x, y, and z. So you define a vector. And if you borrow this in quantum mechanics, you can define a wave that's a wave function that exists or composed of two situations or two states, partially exist in state, for example, like 0, and partially in state 1. Then you can borrow the same kind of representation from this analytic geometry into this. And this is, we call it the bracket notation. And this has been developed by Paul Dirac, and it has been simplifying a lot of representation about quantum mechanics and modern quantum mechanics as well. Several things we need to pay off because we are going to use them in debugging. The wave function should be normalized. It means that all probabilities should be added to 1. So you need to add this one. So feel free for more details to revisit the slides so you can learn more about this. I'm just summarizing things, and then we are going to come to the quantum lab where you are seeing the details. And the total sum of the square of those coefficients will add up to 1. So this is like the coefficient times the complex conjugate of this coefficient, and the square of this will equal to 1. So it's used all the time in debugging. Okay, after we come to these nice examples, we have this funny example that if you have a cake, this cake also, you can describe it using a direct notation because the cake is composed of sugar, flour, but also you can add a chocolate and many things you can add. And this is, you can have a partial way of this representing it using direct notation, like the kit of cake will equal to alpha chocolate plus beta vanilla plus gamma strawberry and delta lemon and so on. So you can have a linear combination or you can add up all of these things. Of course, this is just like a sort of like a friendly joke about the quantum world. So we come now to the concept of quantum. We rely on storing information or manipulating information in quantum computing using qubits, and we have the classical bits. It just has one defined state. Either it could be a switch that's on or off, so we have 0 or 1. The qubit is by default a classical bit. However, it has an extra ability, like an extra superpower. And this extra superpower, it means that this qubit can be in a superposition of 0 and 1. So you can perform an operation that makes the classical bit, which is a quantum system that behaves as a classical bit, jumps from being in 0 suddenly to be between 0 and 1. And this is how we describe the qubit. So we use the qubit that exists in 0 or 1. So it's like a binary system. So we describe it by a column vector, which has 1, 0, and then we have another 0, 1, and so on. How we can perform a matrix multiplication. Of course, you can just review this. I would assume that all of you know this, but if not, then you just can revisit the slides here. Okay, so now we come here for the last concept that we need before we step into the lab. So in order to manipulate or do some actions on the qubits, we need quantum gates, which is sort of unitary operations that act on the state of the qubit to do something. And this is like if we, for example, have this thing. So you can define like qubit like this. Let me just define a white space. So you can have something like this. This is your qubit vector. You add a matrix that acts on it. This is your gate. And you get a new quantum state here. And this is what we call psi prime. So the only thing is how we can describe our quantum circuit as a gate or a one big gate, one big matrix acts on a state. And then we have a new state, and then we need to extract the information that we need from this new state. So you will find also in these slides many examples about how to use these gates, different types of gates, and so on. And then, for example, how to apply a specific gate and what it does it do on a particular qubit. Like, for example, this X gate, it's called the Pauli gate, and it flips the state of the qubit. And instead of being in the 0 state, it now transforms it to, or projects it to the 1 state. So we get 1. So we were in 0, we just flip the qubit to 1. We can now have also another gate, like for example, Y gate, and this does a specific action and so on. So it adds, for example, like -I or a complex conjugate. Those gates or these things manipulate the phase of the qubit. So when we describe a qubit, we can describe them using some angles, and those angles are represented on using spherical coordinates. on a sphere. We call it unit sphere. And this unit sphere that's used to represent the state of the qubit, it's called a Bloch sphere. And a Bloch sphere, you can just have a qubit with a specific state, and then you have some angles like theta and phi, and you can use those angles to represent the state of the qubit. How does it look like on this? So, for example, if the qubit in state 0 means that the vector, the corresponding vector that represents the state of the qubit is coincides or lying on the z-axis, on the positive direction of the z-axis. When we apply the X gate and it flips the qubit, it will go to the negative direction of the z-axis. So using the angles theta and phi, we can know the location of that vector, and that will tell us immediately about the partial coefficients, what is the coefficient next to the kit 0 and what is the coefficient next to kit 1. If we come to some examples, you can find, for example, here, the state is coincides with the z-axis. If we go here, it now goes to the negative direction of the z-axis. And here it's now coincides with the y-axis, so with the x-axis. So it's in between. So we see half, 1 over root square of 2. So it's in between the positive z and the negative z, and so on. So you can have this. So just by showing where this arrow do exist, where this arrow does exist, we can just know immediately and figure out immediately the coefficients that represent the state of the qubit. We can play with the state of the qubit, and we are going to see this in a moment using these links. Okay. Let's now go to the quantum lab. Okay, so I'm gonna just show you some actions of these gates, and then we are gonna go to the breakout rooms immediately after. Okay, so now this is an intro notebook. It just introduces what kind of libraries do we need to run the code, and how do we need initialize a qubit. So there's a bit of classical software in the beginning, tells you how to initialize a qubit. So you can, for example, initialize your qubit in 1, 0. It means that your qubit, you understand it in your head, that this is numerically, means that the qubit exists in kit 0. Because computers don't understand these vectors or anything, just only after all we store numbers. We only label those numbers and we make a meaning of the representation in our heads. We can also create a Hadamard gate, and this Hadamard gate will just put a qubit in a state 0, put it in a superposition, and so on. After we do that, we can create a little simulator, and that simulator will tell us how many times we can find if we measure a qubit in state 0 and how many times in state 1. And for example, you will notice that the statistical behavior of quantum mechanics, if you have a qubit that's already in state 0, and you do a measurement, all the time you will get 100% in state 0 because it acts like a classical bit. But if you have a qubit that goes to a superposition between 0 and 1, then you have a probability to find it as 0 or 1 depending on the coefficient that we have seen. And if you do a lower number of runs, like you do 1 run, you might end up having 1 situation out of the 2, which is now state 0. You can do 2 runs, you can end up in the same situation. But suddenly, if you have 5 runs, you can have like a contrast between the 2 situations. And when you increase the number of runs, you get sort of some kind of saturation or convergence. It means that you have already sampled the whole probabilistic space of the quantum state. After that, we see here the actions of the gate. So for example, we have a qubit, and this is using a Qiskit language, and we have a Hadamard gate that acts on the qubit, and that Hadamard gate should put this qubit that's initialized to 0 in a superposition. And then if you measure, you should find it either in 0 or 1, depending on the measurements. And of course, you can measure the state of the qubit. You can also put it in entanglement. You can use several types of gates, like CNOT gate, and so on. In the follow-up quantum labs, which will have sessions by presumably by the end of the week, we'll have more theory discussions. But today, just only an introduction, so we know also your backgrounds, your skills, and your expertise, so we know how we can work together in the upcoming sessions, and presumably what kind of theory and the practical exercises will be needed in the future sessions. So that's what I wanted to highlight for this. You can also visualize the qubits and so on, but the best way to learn is to get your hands dirty with hands-on. So I'm just gonna stop the screen now, and then we are just gonna have 2 breakout rooms, mainly for the programming part. Okay, so let's see. Okay, so just raise your hand for if you understand or you are comfortable with English language as the main language of instruction. Yeah, I just need to see many hands. I mean, I see one hand only. So one person is only happy with English. Okay, 3, 4. Okay, that's great. If you are not, just fine, but I just need to know how many breakout rooms we need to split. Okay, so we have 7 people will go to the English room. So I assume the rest are okay. So just raise your hand if you would like to go to the breakout room with English as a main language of instruction. Otherwise, you will stay in the Arabic one. Okay. So for Andre Barba, what's your favorite language of instruction? Okay, so start this one. So I think, Bashmans Youssef, we need to promote all participants to be attendees in order to have the breakout rooms, or can we have it while they are there?
I'm not sure. Let's try. Seems we can either have participant be an attendee or panelist?
So presumably, oh, I see. So if they are promoted in the panelist, they will be there, and then we can have the breakout rooms, I think.
Okay.
Yeah, didn't try this in the webinar setting before.
Yeah, we'll figure it out.
Right.
I think we'll just have to do them one by one. It doesn't seem that
Yeah,
there's
to
a way
be
to do it in batch. So let's just maybe we can do it together. You're also co-host, so
yeah, you're right. Yeah, that's okay.
I can start from the bottom of the list, maybe.
Yeah, then I will start from the up.
Okay.
I think I finished all of them, but I think it takes time for them to.
Yeah.
Okay, it seems for me the option with breakout rooms is not active. So, okay, so I would assume that maybe the best way is to, okay, while I'm approving people to become a panelist and enter the main room, for Gamal to start the highlighting the installation and the running of the notebook. And then we just see, we just see. So we are gonna now start with Gamal the first notebook. And then you are gonna just all make sure that you have downloaded from the link, from the repo, the notebook, and you can just consult with him about the installations that you need or what kind of platform you are using, Collab or anything. And once you are running, whenever you have technical questions, we just can discuss it also, Gamal, Dr. Mohammed, and I with you. So yeah, Gamal, please feel free to start.
So I will share screen.
Yeah, now I'm not sure about maybe we are sticking to English. I'm not sure if there is anyone speaking. All of them are speaking Arabic, or we have some people who are speaking English only. So it's not visible for me. So yeah, maybe you can make a mix or yeah, whenever you find appropriate.
Hi, Taha.
Hey, Andrea.
Do you hear me?
Yes, I hear you.
Okay, now it's possible to communicate. English is okay for me. It's okay for me, English. Don't worry.
Okay, so thanks because we didn't know who's speaking Arabic or English about this, and then I didn't see any hand raised from you. So, yeah, we're a bit so okay. Thanks for letting us know.
And today is all the idioms, not problem, no, with Whisper translate. AI is possible change the language without problem. Yeah.
Yeah, I would assume so. Yeah. Indeed.
If I record the meet, later I translate with Whisper of the open source, the OpenAI, and translate for my language. Today it's
Okay.
possible. Okay.
Yeah, that's nice. So Gamal and I were working on a project to use Whisper also and some other AI models to work on language translation also for audios, for podcasting and the videos as well regarding to the YouTube channel I present. Okay, so Gamal, feel free to start presenting you the notebook.
Okay. I just sharing my screen.
No, I have learned it also as Andrea has said, and Ahmed, you can also use a caption in Zoom. I don't know if it is really fast or not, but you can just use it as well. So for those who decline to be a panelist, it's just only for you to ask questions about installations or any, to interact with us. Otherwise, it will be very hard to hear from you. Unless you are just want to be ideal listener, you need just to be in the main room because we don't have a breakout room option at the moment.
We can split and use Discord for Arabic and Zoom for English, or we cannot.
Yeah, sure. If everyone is on Discord, that also could be the case. But then you can just, because now we are in the recording, it's better to explain things here and then for debugging on Discord.
So for the installation, we can use Anaconda it will be easy for Windows user. So just download it and launch it. Okay. Yeah. So we can use Anaconda, just creating an environment from, yeah. So just 1 minute. So my Anaconda navigator is showing up in the screen share or not?
Not, is not. We only see now the web browser.
Yeah. So we should just download it from here. Uh, Now we can see the navigator.
Yes.
Okay. So just download the Anaconda navigator from here, based on the operating system, and just creating a environment, new environment. You can do anything using Python. But it takes some time, so we'll use this one and choose the environment we create from here. And we can use VS Code or Jupyter Lab. I will use Jupyter. Just taking time to understand. I am not using Anaconda, that's why it take time for opening. But there is another option to use mini Conda or Conda from terminal. I think it's because my storage is not allowed me to install something new, but we can use PyCharm, but we have to. If you don't have it, you can download it from JetBrains. From here and then launch it like this, and we should clone the repo. With this command. I already clone it and open it to PyCharm and set up the environment. We can add from the setting, use the Python interpreter, add new one. From here, we can generate new or select existing. Can use Panda or other virtual environment. And just run it from there. Okay. Dr. Taha.
Yes, I'm now trying to unmute myself. Yeah. So thanks, Gamal, for the nice installation. So hopefully everyone now installed it, or raise your hand if you have just installed the Qiskit or Anaconda, and if you have it, or you have it already installed, or you are gonna use something different to run Qiskit. Yeah, just raise your hand if you managed to do the installation. Okay, that's interesting. Yeah, okay. Abdullah just made started the ball rolling. Nada, okay, that's nice. Also feel free if the installation is a bit complicated. Who's else? Can you raise your hand? Okay, Asma. Okay, if you also if you are not able to install it, you can just use Google Colab, which you can just from your Gmail account, you can just use Google Colab to run this, but you need just to install Qiskit. Yes, okay, done so. So if you would like to use Google Colab, that's fine. We are just showing both options, so that's the idea. Okay. So let's do something all at once. Raise your hand if you can just run Qiskit today. And the rest, are you able to run Qiskit, or only we have 5 who are gonna really run the notebook live? Okay. So, okay, we see here 6 hands, which is nice. So, Gamal, so feel free, Gamal, now to run the notebook and they will just follow along the way.
Yeah. So so everyone have the repo, or should I share it? Or
I've shared the link with them in the chat,
okay.
and also, yeah.
So the first one. Okay, I'm using PyCharm. So the first one, uh, yeah. So we import numpy and matplotlib, and then initialize the qubit as you explained. I think collab there will be a conflict with Cascade version with this one, because I tried collab. So here we initialize the qubit, and then we apply a Hadamard gate. Yeah. And then here we apply Pauli X. Gate 0 and gate 1.
So, Jamal, can you enlarge the font a bit?
Okay. is the measurement, visualize. Yeah. We should install Qiskit here, like in Collab or something, and then run it like this. I think there is exercises at the end, or no? Mm.
Right, there is some questions to answer at the end, but for the notebook, it just will have it introduces some kind of the skills and they make them like familiar with Qiskit language.
Yeah, here.
Like yeah, this one for example.
Should we try the other notebook or oh,
So Gamal, if you'd like to send it to everyone, you need to choose the category to everyone. You will find it when you send, you'll find a panelist and host and the panelist, and then everyone.
I don't have everyone to see. Also,
Oh, I see. So I'm just gonna then copy your
I think I
messages.
can.
Okay, so Domdom has sent you this, and Jamal has sent you this one.
So I can push the requirement text file to the repo. I think it will solve the problem.
Yes. Let's check why is this. So I think, do I need to approve anything? I didn't receive anything at all.
Yeah,
Yeah, nothing is visible at my site.
yeah.
Or maybe then you can just share it on Discord
And-
for now until we see.
Okay.
So just, so if you are all on Discord, which is highly recommended, also you can put the requirements of the quantum lab there on the channel. Gamal has created Quantum AI Fib 2025. Okay, if things are going well with you, let us know in the chat or raise your hand just to know that, yeah, things are working with you smoothly. So, yes, please. Yeah, so feel free to raise your hand if you are working on installing Qiskit. So I would assume now Qiskit, all of you have Qiskit working and up and running somehow. Is it correct? Okay, then so has sent thumbs up. Okay, so okay, I see on the group some chats about this. So then while you are installing, if you have any question, just feel free to ask. So is everything clear for all of you? Okay.
Yeah, I have pushed my the requirement file to the GitHub repo.
Okay, that's great. Yeah, thanks, Jamal. I'm now checking. So does anybody have a question or anything for us? Okay, then I assume we can continue.
Yeah. So we should go to the next one, the next notebook. The previous step.
So there's a question, Jamal, about shall we pip install by latex ink?
I have uploaded this file, the requirement file.
Okay, it's 2.10 version. Okay. Okay, that's great. So please follow the requirement file because you are gonna need this latex package and also some display of equations coming from Qiskit. If you'd like to see some equations nice and tidy in your output.
Yeah. So we don't have any exercises here for the next one.
Yeah, just people feel free to run things and try to understand the working mechanism of the application, like how to create a quantum circuit and declare qubits and so on. And then after you run this, we are gonna discuss a bit of the physics about it.
Yeah.
Yes. So for Jamal, still also I think the user DomDom has an issue about the missing bilatic ink. So please follow the requirement file, install the requirement file and the specific version that has been mentioned in the requirement file. It has been now pushed by Gamal to the repo.
Yeah. Think the issue is here in collab. issue having in this function?
Oh, okay, you mean the drawing.
Yeah,
So I
but in
think yeah, right, to solve the drawing, we just need this one, because sometimes it's a problem in matplotlib. So please add this at the beginning of your notebook, this command. I'm also gonna add it in the Discord.
keyboard. Think we should add Seaborn as well.
Yeah, is everything working right and well with everyone? I would assume that the silence means yes. Okay, that's great. Thanks, Abdurrahman.
We have here like nation.
Yeah, I have used it for this notebook, the new Cascade 13.1.2, I think.
Yeah.
And this one, yeah, that
Have
has to be updated. Yeah. Of course, the best way is to have a virtual environment and so on. But indeed, if someone have a fresh installation of Conda, they won't worry much about this. Okay, so a bit of a discussion about what we are doing now and what Gamal is showing. So we are gonna discuss this in the follow-up quantum lab. This is today is just to get the programming session to start, and also to solve the installation issues and make sure that you can run the notebook correctly without any error messages or anything. Today and next time, what we are aiming for is to cover how you can create quantum register using a specific number of qubits, and how to get the Hilbert space or the Hilbert vector representing the quantum register, how to create a quantum circuit that can manipulate the state of the quantum register in order to perform certain computations, where these gates are arranged in a sequence, a specific sequence, to do some computation, and then do a measurement to retrieve the value, because quantum computing, we are dealing with black boxes. You have something in that enters the system and something that we can have it as an output. And then you can speculate in a simulator on what's happening inside, but always this is in the quantum realm. We don't have access all the time to. We can speculate about it. So when you measure, you have a certain value, and then you need to correlate this value to the output of the algorithm that you are looking for. If you have any question, just feel free to ask about the programming or about the physics. Okay, so if not, I assume that things went well today. We are gonna send you the time for the next session of the lab. And today we had also our nice quantum mentors, Bishmans Gamal Moneep and Dr. Mohamed Yehia. And Dr. Mohamed will have a visit on the Quantum Innovation Summit tomorrow, so that's great. So he will have a peek about what is happening in the newly emerged quantum buzz ecosystem in Dubai. So that's
Inshallah.
nice. Inshallah. And together with Bashmandis Gamal, we are working on a project related to the quantum lab, and also make sure that we have enough use cases and the projects, and also with the help of Dr. Mohammed and other members of the Quantum AI Lab, we are gonna publish use cases that about using quantum computing and AI, for example, in some vital domains like chemistry and the battery design, and also in quantum machine learning. And those you can gradually, we are gonna grow our skills and the knowledge in quantum computing, but also in the other domain fields. And we are going to work together in achieving the goals of these use cases. And maybe we can publish some software on the internet, and also some presumably report or like a pre-paper on archive. So that will be also a great way of showing what we are learning and what we have learned during every session. Okay, so I'm gonna leave the final words to Dr. Mohamed, Jamal, and Bashmandis Youssef. Dr. Mohamed, the mic is yours. Final words to conclude the session.
You are talking to me, yes?
Yes.
Yeah. I mean, it's a great step ahead. Okay. And yes, I hope that everybody can start after installing Anaconda, so they can try to practice. And you mentioned that you will provide some training cases. That will be great until the next time. So everybody should try as much as they can with those cases. Because I know this kind of application needs time and effort, I mean, to get familiar with, and also to understand what's going on, because sometimes you come to a point, you don't know what's going on, or you don't understand the output. So, and the easy way to do this or to overcome this is to just practice and to look at different cases, especially those critical cases, as you mentioned, Dr. Taha, related to battery design and chemical things. Yeah, I think this is the most important thing, is to provide cases, and everybody now, I guess, they can install or reinstall even on different laptops or different computers, and they should start from today to practice until next time. And of course, we will be support everybody in terms of physics, in terms of technical from your side and from your colleagues. Yeah, that's all. And everybody should feel free to contact, because especially in the first steps, everybody needs support, needs interaction, discussion. I know today is a bit hard. Usually beginnings are, or first steps are, those are the most heaviest steps ever. And then once they started, everything will be easy, inshallah. Thank you for having me today, and I wish all the best for everybody.
Yeah, thanks to you, Dr. Mohammed. Yeah, Jamal, mic is yours.
So thank you. I don't have too much to talk, but I wanted to talk more about use cases, or we should do, or it will be the next time.
Yeah, that's great. Yeah, we're telling that we are gonna prepare a few draft projects for next times, and hopefully with the progress, as Dr. Mohammed said, they achieve the required skills and the knowledge to also proceed with it. And feel free to contact anyone. Don't know if Bashmandis Youssef Eldakar is still with us, not to yeah, say as a final word also as well.
Yeah.
Yeah. Yeah, thank you, Gamal, for this nice tutorial and for getting us started with hands-on work, which is very good to see. It's really working toward our target to be able to work with quantum computing hands-on and develop solutions to problems. That's very good to see. So thank you, Dr. Mohamed Yehia, and to Dr. Taha, of course, especially for preparing the notebooks, which I think are very good for someone to get starting. All the best, and looking forward to next time.
Yeah, thank you, Bashmandis Youssef, and thanks for the organization and everything. And thanks also for Bibliotheca Alexandria. If there is someone is helping here, or I don't know if the account of Bashmandis Youssef, but yeah,
Yes,
special
our
thanks to the team.
Yeah, yeah. Thank you very much.
Yeah.
It's to our pleasure. And BA is very happy to be collaborating on this together.
Yeah, thank you very much, and thanks everyone. We are gonna be in touch, usually on Discord, but also on our other social platforms with the upcoming dates for the quantum lab, the programming lab dates, and also the upcoming monthly series, which presumably will be about, as discussed yesterday, about modeling, how to establish a computational model, and also how to create a computational model for chemistry using quantum computing, and also design or develop a computational model for classical physics problem and the quantum physics problem. And with this kind of knowledge together with programming, there will be enough foundation to proceed with what will be proposed use cases. So thanks everyone. We wish you a great time.
Thank you.
Yeah, thanks.
Thank you all.
Thank you.
Next
Assalamu
time.
alaikum.
Yeah.
Wa alaikum assalam.
Salam. Wa alaikum salam.